All right, this is the practice activity we did in class today to help prepare you for the quiz tomorrow. So let's look at problem 1. Problem 1, the first sentence says, what is the solution of the quadratic equation 2x squared plus 3x minus 19 equals 0? So when we see the word solution, I want you to think of your answers, your x-intercepts, your zeros. All these words, zeros, x-intercepts, okay? So x equals is what we should get, okay? Then the second sentence says solve using the quadratic formula. Well, let me add x equals here. This is the quadratic formula. But in order to do the quadratic formula, we have to set equal to 0, which looky here, this is awesome, it already is. So that's great. So once it's equal to 0, now we have to figure out what A, B, and C are. Well, the number in front of x squared is A, so it's 2. The number in front of x is B, and the number without a variable, including the sign in front, is negative 19. So now we're going to take all these numbers for A, B, and C and plug them in to the quadratic formula. So if you notice, it is something plus minus a square root all over something on the bottom. So let's start with opposite B. In front of the plus minus, we need to take the opposite sign of B. So if B is 3, negative 3 goes in front. Then it says B squared. In parentheses, B is 3 squared minus 4 times A, which is 2, times C, which is negative 19. All of this over 2 times A, which is 2 times 2. All right, so now what we need to do is rewrite this as negative 3 plus minus square root all over 2 times 2 is 4. What goes in underneath the radical? Well, we're going to take all of this and put it into Desmos. No square root, no radical goes with it. So we're going to go to Desmos and we're going to type in, let me get rid of this, parenthesis 3 parenthesis squared minus 4 parenthesis 2 parenthesis negative 19 parenthesis. Be careful, that negative needs to be there. And then our answer is 161. For you guys in Algebra 1, every number that goes into the radical right here should be positive. None of these should be negative. And here is our 2 answers. All right, let's move on. Let me erase some of this. Let's go on to number 2. A quadratic function is defined by, another equation. Let's put this into Desmos in a minute. Let's see what we're looking for, though. Write your answer as a product of 2 linear factors. Factors mean parentheses. 2 things that multiply each other, okay? All right, let's put this equation into Desmos. Let's see what we get. Let me erase what we did a minute ago. So 2x squared plus 10x plus 8. Now, the first thing you're going to do is we're going to click our 2 x-intercepts. So we have negative 4 and negative 1. These are our solutions, not our factors, but solutions. And I'm going to show you today how to take solutions and turn them into factors. So I'm going to go back here and I'm going to write these down. So we had x equals -4 was 1, and we had x equals -1. But we need to turn them into factors. We have 2 solutions, so 2 factors. All right, a factor generally looks like, when we're talking about quadratics, looks like x plus something or x minus something. So we have to take this x equals -4 and make it look like x plus or minus 4. Now, how do we know whether it's a plus or a minus? Well, you're always going to do the opposite of what is here. So we're going to take the opposite sign. So if this is a -4, I'm going to write x plus 4. If this is a -1, then I'm going to write x plus 1. Now, why did I do that? Let me show you. If I set x plus 4 equal to 0 and I solve for x, I'm going to subtract 4 from both sides, and I end up with x equals -4. Look at that. I end up with the same solution that I started with. That is why you change the signs. So in these 2 sets of parentheses will be x plus 4 and x plus 1. Now let's see if you really learned this. Let's take our equation in number 3, put it into Desmos. Here we go. Let me clear all this out. So x squared plus 4x plus 3. Let's click on our x-intercepts, and we have -3 and -1. Okay, let's go back. So I have, let me get my other color out. We have x equals -3, and we have x equals -1. So I have 2 solutions, so I need 2 sets of parentheses. And remember, we're going to do the opposite sign. So this is x. The opposite of -3 is +3. And then we're going to do it again, x. And the opposite of -1 is +1. So both of these go here. Now, could I check? Let's see. I'm going to set it equal to 0. Subtract 3 from both sides, and look what I get. X equals -3. That's what I started with. So I know I did it correctly. All right, let's go on to problem 4. A penny was dropped off a building in the middle of downtown Roswell. The height in feet of the penny above the ground, t seconds, after being thrown, can be determined by the expression -16t squared plus 4t plus 50. What is the meaning of the 50 in the expression? Okay, let's put that into Desmos. All right, here we go. -16, can't put a t, so it's x squared plus 4x plus 50. All right, here we go. Let me make this so we can see it. Okay, I'm actually going to make it just a little bit taller because I really want to see up above. Now, if I click on my starting point, remember, all this out here is negatives. I only care about the y-axis and the x-axis. Only this section. I don't care about any time there are negatives. Everything should be positive. Let me make this just a little bit bigger so we really can see. All right, so if I click right here at the y-intercept, 50 is the starting amount. Okay, so let me go back here. Let's talk about this. Let me get my pen. So right now I know 50 is the starting amount. And I know that because I know that the y-intercept is also another word for starting amount. It's the y-intercept. Well, if I started at 50, that means when I dropped the penny, that's where I dropped the penny, is at 50. So we could write, let's see, how could we write this? 50 is either two things. 50 is the height of the building, because that's how tall the building was, because that's where I stood on top of a building. Okay, it's the height of the building where, here's a word, where the penny, let me write this, was initially. Initially means starting. Initially thrown. That means the starting amount. So 50 is the height of the building where the penny was initially thrown. I stood on top of the building in downtown Roswell, and threw off a penny. Okay? Now, that's all I asked you to do, is tell me what the 50 meant here. But let's see if we can answer this question. So let me put another equation into Desmos. So let me do it. Oops, that didn't work out. So plus 32x plus 100. Now, I'm going to shrink this down so we can see it well. So remember now, I do not care about what happens over here on the left side of the y-axis. I only care what happens in the first quadrant. So look, this time the starting amount is at 100. Let me make this so we can see it. Okay, we started at 100. The highest point is 116. That's how high, because remember the y-axis is all about the height. And then I threw, this is a water balloon one, I threw my water balloon. It got to 116 feet and then it fell to the ground, and the x-axis is the ground. So it took, the time we started was 0. That's when I was at 100 feet, is 0 seconds. Time is the x-axis, height is the y-axis. It took 3.69 seconds for me to throw it, and it hit the ground. So let's see if we can go answer some of these questions. So what is the maximum height of the water balloon? Well, that's the highest point, so 116 feet. How long did it take the water balloon to hit the ground? Now it said to round to the nearest hundredth. So I just need 2 decimal points after the decimal. 2 numbers after the decimal, making sure you round correctly. So it took 3.969 seconds. Then it says, what was the height of the water balloon when it was initially thrown? This is your starting amount. Starting amount. So how high was it when it started? You were at 100 feet. Now, if you're paying attention, look at this. The number 100, this is your y-intercept. The number 50 is your y-intercept. So right now the starting amount is the number without a variable. All right, move on to page 2 for the back.